I don't know how much I can officially say. So, I mean, we do some analytics work. We have some contracts with some government organizations as, you know, subcontractors, and kind of leads on that. But like I said, I don't know how much I can actually say on that, unfortunately. So, any other questions? We do work and we do sponsor and host an event every year called Hack the Machine. We just finished it in New York. One of our sponsors is Booz Allen, which obviously is on the 8th floor with Army Futures. And so there's a big, this year, there's always a big data science track. This year it was on classifying malfunctions or if there's any sort of maintenance that is on FATs, right? So it is partnered with the Navy on that one. Yes?
Is it going to come back to Austin?
Historical? This version, probably not with a couple years. Next year's event site has not been hosted yet, but we are sort of in talks with Army Futures, but that is like very, very, very early stages. So we'll see on that one. But we were here in Austin.
On YouTube. What am I doing in Slack? Just gonna make sure that this gets posted. All right, so we're gonna get started. So 10 years, it was November 2009 that Rob Pike and Rod Geisinger shared an office at Google. I don't think that they were actually sword fighting. You know, these are some of the greatest computer scientists of our time, obviously, and they were waiting for their code to compile. 50 minutes apparently. I don't know where the citation for that is, but so they had some ideas on writing a new language, and at Google, you know, they have huge systems that need to interoperate, and they really needed a language that was purpose-built for a lot of people to collaboratively work on a really large software project without suffering from a lot of the problems that they're used to. And so that's to eliminate slowness, eliminate clumsiness, improve effectiveness, and improve scale. And so after 15 months of development, they actually released Go open source on November 10, 2010, or 2009. And they launched a website, really basic site. And does anybody remember, like, when it was first released? Did anybody happen to catch that announcement? I know it was on Hacker News. I feel like I saw it, but I definitely got more interested in it, probably around 2011. But you know, it very quickly kind of got a lot of interest behind it just because of the people who made it, you know. So it was definitely still a very small language in 2010, and you know, the creators would travel around to conferences and talk about Go, but it was not at all very big at the time. And a lot of the early releases were focused on improving stability and performance. And so in 2011, GoFix was introduced, which is, you know, kind of a refactoring tool, and probably the first, or one of the first of many refactoring tools for Go, which, you know, that's one of the things that Go is really good at, is having, being able to programmatically modify your source code. The, you know, the formatting is all very prescribed, and so, you know, even early on, you know, a lot of the design ambitions of the first developers were starting to be realized. So a lot of the early, let's see. I apologize. I read through these slides once. This is not my talk, but I'll try to get through these. But this was compatibility was a big guarantee in Go. This says it's the first language to make a compatibility promise. I don't know if it's the first to make that promise, but it's certainly the first in my experience to really stay true to that promise. Pretty much, I think I never had, well, and this is a guarantee, right? I've never had Go code that stopped working with a new release of Go. Maybe libraries that I was using that weren't part of the standard core library had changed and introduced compatibility problems, but Go has made it a guarantee that all code that you write will be compatible in future versions of Go. And this is really important for Google, obviously, because they are, they have millions or billions of lines of code that need to interoperate in a lot of cases, and compatibility is just a big part of that. March 2012, Go 1.0 was released, and this major Google service, dl.google.com, was rewritten into Go, and Brad Fitzpatrick, who's a big Go contributor, did a talk about that. It was really good. And this is about the time that I was starting to get really interested in Go. And I actually started the meetup in 2013, which I guess was right after Go 1.0. So 1.0 introduced the append function, introduced error and rune built-in types, and a complete rewrite of the time package. 1.1 introduced the race detector, which is super useful. So this is to detect data races if you're trying to access a variable from two different Go routines at the same time without using mutex locking or channels. There was a lot of improvements to GC, as well as making map a lot faster. The scheduler was rewritten. They stopped requiring return and panic in all functions, and they switched to doing a 6-month release cycle. So scheduled releases every 6 months. So this is definitely a big cleanup release, I think, after the 1.0 freeze. And then in 2013, the first 2 Go conferences were held in Tokyo, and so the first Go conference wasn't GopherCon, like what the conference we're probably all we're all familiar with, but GoCon in Japan. And actually, that was a month after the first Austin Go meetup, so we apparently beat the first conference by a month. And I think at the time,
when was the first Austin Go meetup?
It was March,
March
2013. And I think at the time I saw there was probably around 10 meetups in the U.S. So
it's just ironic because now we kind of avoid March meetups because of South by.
Yeah, actually, and I do know that the first meetup was at a bar, and
It's not a bad thing.
it's definitely not during South by, at least if I recall. But yeah, 1.3 came out in 2014. Stack improvements, linker overhaul. 1.4 introduced Android support, and I think I remember from that time period, Ian giving a talk about. Well, you actually had Android. You had your phone running Go at the time, so I don't know if anything ever happened with that. I don't know. Is anybody writing big Android apps in Go without it? Yeah, so they moved from Mercurial to Git, which actually, when I read this, it surprised me. I didn't know they were ever on Mercurial for Go. But, if anybody doesn't know what Mercurial is, it's just a very weird version control system that predates Git.
Can I interrupt real fast? I'm sorry. I have uncharacteristically left my USB-C adapter somewhere else. Does anybody have one I can borrow? Yeah, USB-C is the only port I
You
get.
can ask Echo Factory that.
Yeah, I know. I just thought before I did that, I'd ask the room. Let's see. Thank you. Anyway, sorry. I have one like lives in my backpack.
You have like all your other.
No, I
hardware.
just need to like this guy. Hmm?
You have like all the other hardware I could imagine.
Oh yeah, if you need me to crimp something.
You
for
might be able to
gotcha.
make a USB.
Which is,
stick.
you use like
Probably.
airplane,
Huh?
the airport or whatever thing? Airplane?
It's just the port that plugs in here is all I need. I'm not really confused about what I need.
How much?
Cool, thank you.
So continuing on, yeah, 1.4.
I have one of these. It's not.
I think Mozilla actually still uses this for Perl as well. They haven't switched yet.
So 1.4 introduced GoGenerate also, which means 1.4 semi-introduced generics, but that's a topic for another
What?
day. But yeah, I would say around this time period, Go is starting to really explode. I mean, our meetup went from 5 people on average, or even less sometimes, to
Like 7.
yeah, to like the whole 10. And,
Depending on if they could find us that particular like quarter or whatever, since there was
Yeah.
a lot of headquarters changes.
we definitely had a lot of movement around different locations, and some of them required video presentations on how to find. So we like it here. But yeah, in 2014, a bunch of new conferences started to show up. A lot around the world even. I believe that was the first year of GopherCon, right? So I was in attendance at GopherCon that first year. And then also in 2014, Docker runtime was rewritten in Go. Does anybody remember what Docker runtime was written in before they rewrote it? Was it C or? I know that like a lot of Docker was written in Python at one point in time, and I wasn't sure if the runtime itself was somehow, I don't know, is that even possible?
Yeah, I think Docker.
The Docker runtime was written.
I thought you were saying the Go. Like the Go compiler.
That would be wild, running on Python. But yeah, so I mean, major projects started to adopt Go around this time. Kubernetes, obviously, the biggest Go project ever, was open sourced in 2014, and that came out of Google as well.
Whoops, sorry.
And at this point in time, there were 500 contributors to Go, so people that authored the patches to Go. 2015, 1.5 came out. More work on the compiler and runtime. Well, they actually rewrote it in Go, so they have a fully bootstrapped compiler. And that, I think, opened up a lot of new changes. The garbage collector is always, I feel like every release, there's something to do with the garbage collector, but they added concurrent garbage collection in that release. And I think, before this, like, most Go programs were by default running in one thread. So I think that this was kind of a lot of Go becoming more possible for parallel programming. And then vendoring as an experiment became possible in 1.5. So that actually allowed new dependency management tooling to start coming out, which that definitely changed a lot. I mean, allowing vendoring or allowing you to have a directory that you can point to have dependent code pulled into allowed a whole suite of tools to start developing an ecosystem to allow you to manage your dependencies more clearly. And yeah, so and then in 2015, more conferences, more organizations, Women Who Go started, and GoBridge. So a lot of educational outreach and worldwide conferences. And then lots of releases, like I said, every 6 months. So in 1.6, HTTP2 was introduced. Transparent HTTP2, which I think that just means it just works out of the box using standard net HTTP. It'll serve HTTP2 if it's available. The context library became part of the language, so that used to be a sort of a third-party package, and if you're unaware, context is sort of it's an object you can pass into all functions that are part of a request response cycle that lets you do stuff like pass data along through that. So you can do stuff like tracing, you can do debugging with context. You can use it to track usage of different resources. So if you cancel a request, you can roll those all up. So really useful part of the language that I think is pretty essential to learn. More community stuff. I'm not going to read these all off, but lots of conferences, top 5 most loved languages according to Stack Overflow. This book, apparently, I think, I don't know what language that is, but it's something Asian. Korean. Good eye. Then 1.8 had so GoPath used to be something you'd always have to specify when you ran Go code. You always had to explicitly define this GoPath variable. And there are actually, in older versions of Go, there were like a ton of different environment variables that were either required or optional. But I think 1.8 is the first release where you didn't have to have any like weird environment settings. It assumed some sane defaults. And then they continued to modify and improve the GC, and this was the first release to guarantee sub-millisecond pauses. So, with garbage collection, you always have some amount of time you're having to wait for it. Sub-millisecond really means that GC shouldn't ever be an obvious artifact in user workflow experience. So that was a pretty big one in terms of usability and, in operating a user interface. 1.9 had type aliases, which are something I don't use at all, and maybe I'm missing out. But and then in 2017, for the first time, it's according to something, I think Stack Overflow, it's the #1 language that developers want to use. 1 million users, 13 conferences, and a contributor summit. 2018, 1.6 million users worldwide. Did that go from 1 million to 1.6 million? So that's pretty good growth. And 7.2% of developers use Go in a Stack Overflow survey. And yeah, it's one of the #1 languages already, at this point in time. And yeah, more fun facts. And then so last year, 2018, the 1.10 release included some new toolchain and runtime improvements. I don't have any more details than that on this one, but really, I think the biggest change in the last couple of years was Go modules. And release in 1.11 is sort of an experiment, but this is really the sort of from the top blessed version of doing dependency management in Go, and also opens up kind of a different workflow for managing your Go code, where every project can contain its own isolated dependencies. And in 1.11, it was just a very kind of bare bones version of this that was disabled by default. And as more releases have come out, it's kind of become the de facto standard now that I think probably most people have switched over to. And obviously there's a bunch more conferences in 2018, and then we also got a new logo. Go 112, GoVet no longer supported and replaced by built-in analysis tools. So And actually, I don't know a whole lot about the built-in analysis tool, but I think mostly people are using, a whole suite of linters in place of this now. GoLang CI lint is the one I use. So, and then 1.13 is the most recent release. It introduced a way of doing, or basically chaining errors, referencing errors in a way to where you can create a chain of errors. And it's hard to explain that succinctly, but basically new error handling, number literals, and a Go module proxy, which that's the module proxy is an awesome new feature that lets you not have to rely on your Go modules, the original paths of them being available. So if one of your dependencies goes offline or GitHub's down, it allows you to have a place where you can fetch your code, including the checksum database, which is a way of validating that your code that you're getting from your module mirror is actually valid, and gives you some security guarantees that when your code's committed, then that same version is always going to be built. It allows repeatable builds. So really necessary, needed feature, I think, for good dependency management. And then also, so this year the Go Developer Network was launched, and we're actually part of that, which is a worldwide community of different Go meetups and conferences. And yeah, we're one of 54 groups, and y'all are some of 51,000 members this month celebrating Go 10 years. So, and they're the ones who sent us the pins in the bowl back there. So definitely grab one on your way out. They're very limited edition. More stats. You can read those. I'm not gonna read them off, but Go's blown up a lot. I don't have all these numbers for earlier in the slides, but yeah, definitely some big stuff. Here's a list of all the Go meetups, or a map of them. And these are companies that use Go. They did not sponsor. Fathom 5 sponsored. Yeah, and so Go 2 is in the works. There's been a lot of proposals, and it's kind of fun to watch all the drama and public debate that goes on the mailing list for this. There was a try proposal that was pretty epic that failed. But yeah, if anybody has ideas for Go 2, they have a very well-defined proposal process. They require an implementation of it to be considered, and yeah, there's a lot of interesting stuff happening. Obviously the number one feature everybody's always asking for is generics, and I guess Go 2 has generics, so we'll see. I don't know how they plan on doing it.
This is a contracts proposal?
Well, yeah, I don't know if that one got accepted, or I haven't really been following. So Go 1.14 is also coming out soon. This is actually before Go 2, so these slides may have got mixed up, but defer will be faster, and scalable timers, I don't know what that is, but more stuff coming out, including a couple of things we might talk about today. Gaio, or I don't know how you pronounced it, Ian, but it's a sort of a GUI framework that looks like it's got a lot of traction, because Go is not really great for GUI stuff in its current form. Jupyter, I don't know if it already supports Go currently, but that's something I've been wanting to see for a while if it doesn't already. We actually have the Austin Python meetup organizer here tonight, so I know he's aware of Jupyter, but it's it's originally IPython notebook, I guess, right? So it's the Python-based GUI tool or visualizer notebook software. And then Trevor might be talking about TinyGo. What's that?
Yeah, I hope so.
if all the hardware is working.
Mm-hmm.
But yeah, I'm almost done here. Go to's the future, and not much to say here.
Was the TinyGo thing in the official presentation?
Yeah.
Oh, nice. Good job, Ron.
So for the people who have been like filing in, I did not make this presentation. This was a slide deck that was collaboratively produced by the Go Developer Network, and they sent it out to all the meetups, just to give a rundown of what's happened with Go over the years. So I hope I gave this, I hope I presented it okay. So that's it. Happy birthday, Go.
When did Google actually start using it? Because I think there was like a pretty long time that like everyone was using it outside of Google, but like Google itself wasn't really using Go. Do you know?
Well, I guess I was under the impression that they were using it internally.
Yeah, I think he's right. There wasn't like an official language for a little while at first. Like it took some doing before that was the case.
I think they were using it for some projects. They just weren't, it just wasn't greenlit for important things like.
Right.
Yeah, well, I think it was like, what year was it 2014 that Google, dl.google.com switched over?
I don't think they were using it in 2014.
Oh, really?
No.
Huh. That's,
Well, I think they just didn't really talk about what they were using. Because I know Rob Pike would always be very coy about it, but he kind of rather heavily implied that Google Plus used it to some extent.
yeah, it's interesting. I have no idea. But anyway, any other questions? We have a couple other things planned this evening. One of which is this short video that I need to produce, and anybody's welcome to be involved in this. It could just be a couple of us, but I was informed that I need to have everybody sign like a DocuSign sort of thing if you're just like a video release, if you're in the shot. So I don't know, timing wise, we might flip it around and like do the camera pointing this way whenever we do this. But do you want to go first, or should we do the video first?
That's like all of my hardware betraying me at this point. I gotta play around with it a little bit to see if I can salvage something useful besides just showing the fact that a thing called TinyGo exists, and that if I weren't somehow incompetent, you would see a demonstration of it. So you have to give me a little bit of time. I don't know if Ian's got plans.
Okay.
If anybody else has plans. I am curious about modules. If anybody here is, how many people here are like running their own proxy already and have like fully converted to modules? Yeah.
I don't run my own proxy, but I converted all my stuff to one.
Okay, so if you have private repos, you just use like the Go private environment variable?
As a matter of policy, I stick everything in a big ass repo, so no.
Okay, so you have a mono repo, so you're only building third party stuff
Yeah.
in your module?
That's what we did for one of our projects, converted to Go modules, and then for a private repo, did Go private.
Okay, yeah, it's I'm wondering how hard it is to put an Athens server in place and just try it out, because it's kind of painful to make sure like everybody knows to private and chain it in like kind of POSIX compliant array of string paths that are private. Just seems like such a handwave.
Yeah, so we have a lot of private dependencies, and I just built a makefile that everybody uses for compiling
Yeah.
and pulling everything in, and it sets Go private in the makefile.
That's how we're solving it so far.
Yeah. It is a pain to do anything private with like Go private dependencies, but
Yeah, and that particular solution would scale fine if it were like 8 or 10 people doing it. But I'm talking like trying to get this into a much bigger organization it's kind of challenging, because especially since so many people that I encountered are coming to Go new, and it's like they're excited about it, and they want to do it, but there's kind of these like weird little things, like for a long time GoPath now there's sort of, it's like, okay, we got rid of GoPath, but now in order to actually build a project, you still have some like little things you have to set up, you know.
It's like the error message too. It's just like 410 resource connect.
Yeah, no, it's super cryptic, and it's just like, thanks a bunch, like, I mean,
Yeah.
Is this a private repo?
right, is it, like, exactly, and I don't know, it's probably just a good reason to set up our own server.
Yeah, I would definitely be interested in that. And if anyone wants to do a talk about Go proxies and modules, I did a talk on modules earlier this year, but some of this new stuff wasn't out yet. So definitely talk to us. So I guess we're gonna jump in and try to make this video. It's only supposed to be.
Shut up.
It's only supposed to be 5 minutes, or 5 seconds rather, and I guess.
It's a hearing test I'm gonna administer.
Anybody who wants to be involved in the video, maybe just come up here and like crowd around the front, and
It feels duty bound to be involved in the video.
and we're gonna do this, and then you're gonna have to click. I'll send out a link on this after a little bit, but everybody just guarantee to me if you come up here, you're gonna sign this DocuSign thing. This is gonna be anybody who's gonna come up here, right? It might just be you and me, Trevor.
Whatever.
Not Constantine.
What are you been around forever? Get in the video, dude. Sign the thing. Come on, everybody.
I swear this will be
There we
easy.
go. Ian, now get out of this.
You voted. Yeah, I do. With this Alright, so I need one person off the camera. So the idea is the gopher gets thrown into the frame, and then somebody grabs it and then everybody says, "Happy birthday, Go," and then throws it to the other side of the screen. And the idea is they chain it together so it looks like the gopher is getting tossed between the rails. Cute.
Okay. So basically, someone's gonna throw it and someone's gonna throw it back. We're just gonna throw it that way into the darkness.
And I think actually,
Which I think is like too close, shouldn't be, where is it going? Oh.
so somebody needs to take a camera and record from out there, and another volunteer needs to stand.
Which
off
is
to
a part
the
of the
side.
live cast, or is it gonna be a separate camera?
Separate
I don't
camera.
want you trying to open your thing with my face.
So maybe,
There you go.
alright. I will just get my video.
Cynthia.
So, who wants to be off camera throwing the gopher in?
I'll do it.
Okay. Maybe you can jump in after you throw it. And then who wants to be the recorder? Anybody? Alright, and actually, you start on that side, because I'm pretty sure they want us to be on the right.
So am I gonna have a static shot, or am I like doing?
Just hold it still and
So there's
make
one
sure,
frame for the
Mirror image of you right down the middle.
make sure that he's not in the video, and so he'll throw it at us.
Who's gonna catch it? that you?
Yeah, maybe I'll catch it and pass it to you, and then you throw it on.
Okay, how about it?
So let's do a trial first.
Should we have like a Capital Factory logo in the back?
Nah.
No. No?
You gotta give me that.
Now that you suggested that, they're gonna appear in a puff of smoke and demand it, dude.
Squeeze in a little more.
Well, squeeze in maybe.
I mean, we could
in?
put it like on the laptop or whatever.
Like
this way?
Don't kill Cody's laptop by tripping over that thing.
Let's see.
Alright.
Yeah, I've got everyone now, so.
Alright.
Don't do a countdown.
So you just want me to fix it right here? This is good. Like just.
Yeah, just.
And we're gonna say happy birthday, Go.
Yeah, he'll throw it. Let's do one trial, right?
Yeah.
So throw it.
3, 2, 1.
3, 2,
Yes.
3, 2, 1. Happy birthday,
Birthday,
Go!
Go! Alright. Let's try again. Just one more time.
I'm gonna like toss the
Take 2. Alright.
Go wrong.
You'll have it and you'll start it and we'll all kind of say it with you because we realize you're speaking.
Perfect.
Yeah.
Alright. 3, 2, 1.
Happy birthday, Go!
Nice.
Did that look good?
Is that usable?
Looks awesome.
Oh man. 2 takes.
Do you want to do it from the other
Congratulations.
side, just in case? Or no? Are they gonna flip it?
They might mirror it.
wrong?
Oh,
Yeah.
Huh?
Maybe let me read.
Good.
I don't
Okay,
know.
let me, yeah, all right.
Yeah, it'll be fine.
Come on, iOS.
I'm gonna write a Go program to flip it.
Did it work?
Yeah.
Yeah, this
Perfect.
I got one as well.
Hey, great throw.
Thanks.
Excellent.
I love.
All right, so Trevor, should we take a short break, pizza and drink break, or
Ian was gonna show some stuff.
Ian?
Come on, Ian. Show a thing. Huh?
I'm stuck.
All right, so the DocuSign link is in the meetup on the meetup page as a comment.
So one of those things is like typically corporate. Have you ever read one where it basically says they could like draw cartoon genitals on your face and distribute it to the universe until the end of time? Like that's how it's written. It's like no matter what, we can do whatever we want forever, broadcast it anywhere in any medium. It literally says that exists now or is invented in the future.
All right.
They're the weirdest, yeah, they're the media contracts.
Yeah, there's some products do put together.
You just sign your life away to Google.
Absolutely, even more.
Is there a contest to win something from it?
It's all just, the other big
So Ian,
I'm working it, buddy.
all right.
Don't you worry. You're gonna get there. I'm probably just using this too. I'm just gonna wire this button and then we can show at least like the first couple examples. Like I could show sending an actual message from the board because it says Wi-Fi. You don't have a Wi-Fi that you can join unattended with just like values and stuff. And I'll point you. I have a presentation. I'll point you also to this. So the video from GopherCon's past year, where Ron delivered.
It's like 5 or 10 minutes.
Hey Cody, is this Antone's? Unable to connect to Lucinda because the wireless signal is too weak. Antone's. Enter the AirPlay code.
Are you using the members Wi-Fi?
On this wall.
Oh, do I need to be on the regular members Wi-Fi?
No, you're on the right. Well,
I'm on guest.
I think you do have to be on members, but you have to also hit Apple TV on this thing. Oh, it's asking for your.
Oh, well, damn it. I just was able to do that.
I think it used to be you had to be on members.
Yeah, I remember before. Alright. Hey, I don't even know what's going on. Well, it's pretty. Do I have a cursor? Do I have a cursor? This is part of it too? Oh, that's brilliant. It's presenting on here. That's great. Mirror displays.
Backwards.
Mirror displays. Yeah, alright. Lightning Tiny Go. I'm so thrilled that Tiny Go was mentioned in the future of Go because it is a super cool project, but it's also kind of shoestring. And while I am technically a member of the GitHub org, I have done very, very little to earn that. I'm mostly a fanboy of all things Go hardware. many of you have been here in the past when I have talked about GoBot, or we've had like GoBot hack nights. Just to give you an idea, if we have a GoBot hack night, we'll get like roughly 2% of the number of people who show up for like anything with the word Kubernetes in it. So that should be a lesson to you about the true power of hype. It's a real thing. But I love hardware with Go because I kind of came to Go back in like 2012 because I actually wanted to run something on a Raspberry Pi and I wanted it to be easier than writing this in Python, writing this in Ruby, or like diving into this like incredibly opaque, at least to me, collection of tools that's necessary in like C and C++ to deal with like anything hardware. And you know, Raspberry Pi is a Linux computer, right? Like it's a fully featured, quite powerful actually computer for its size. So I had been hearing a lot about Go and I was just sort of like, okay, well this is a thing. It's statically compiled, I can do this. There's some people who have played around with this stuff. So this project called GoBot is actually like the first thing that I got into with Go, and then now I like write all kinds of Go and I do this meetup with Cody and stuff like that, and I spend most of my professional life doing Go like in the cloud and not necessarily on hardware. But the hardware is a lot of fun, and it's a good excuse to learn some stuff. So I first have to say like what's IoT, because we hear IoT all the time, and all I'm going to do is point you to Wikipedia because nobody knows what IoT means. It's a meaningless thing. It's like all the things that are computers that aren't like laptops or desktops or in the cloud is kind of what I think of it. The fact that they say that these are digital machines, objects, animals, or people makes this definition to me kind of like truly creepy and William Gibson-esque. But you know, we now have wearable computers, right? Like people stick things in like jackets and make them cost more. We have like backpacks that have some cool stuff or whatever. And this board right here, this board, which is about like, my pinky finger is like, I guess, 10% longer than this board. And I don't have very big hands. I'm not probably as bad as Donald Trump, but I don't have very big hands. And this thing is so full featured. Huh?
What board?
What board? Sorry. I'm about to tell you, but I just wanted to say like something like this, which I'm going to go into in a second, could just go into like any number of things. And you can imagine this, and it's super powerful, right? So the board is actually this board, which is an Intel Nano IoT, or sorry, not Intel, Arduino Nano IoT 33, which has a lot of really cool stuff on it. We'll get into specifically in a minute, but the technologies that enable IoT, I think, are more interesting to talk about than like this idea of like, oh, it's like a computer that's anywhere. It's like, well, you need all different kinds of wireless, right? We need Bluetooth low energy, right? That can like, maybe a sensor can sit in a cornfield for like years at a time without getting any kind of power update, but it's still an IP address endpoint, which is wild to me to think about. We want LTE, right, for pretty fast data transfer, like straight to your pocket so you always know what's happening on Insta. And then like we need, VSAT, right, to be able to talk at like a sort of a global level to actually send some stuff up to satellites and bounce it around. So we have these like multiple levels of things that are put onto boards all the time. These, multi-radio chips are slapped onto like anything you can think of, and they'll do all three of those levels. Maybe not VSAT on the same chip, but still. We have microcontrollers, which are like special tiny computers that are kind of constructed in a different way from the way that we think of like a, what might be technically termed a von Neumann architecture, right, where we put like instruction code and application code into the same pipelines and run it through the chips because so many things are changing all the time, right? Microcontrollers, you kind of flash a program here and then you have some places where the program's getting executed, but it's sort of separated out. We have crypto now. Like everybody who's got a smartphone that was made like any time in probably like the last 6 years, it probably has some kind of like dedicated crypto chip built in, right? Like crypto is such a big part of the world now because the internet is such a big part of the world that we need to be able to do it in hardware, and we need to be able to do it like super cheap. So one of the tiny things on this, I think this guy right here is actually one of these little crypto chips. It's capable of producing like every cipher in SSL or TLS, which is kind of amazing when you think about it. This tiny little thing can do that crazy math, and they cost like a cent or something, right? If you were to buy them like bare. And then we want to be able to talk to the physical world because that's almost always why we care about IoT, right? We want to be able to have some kind of analog, some kind of digital interface. We want to be able to like talk to other computers, or we want to be able to have some kind of reasonable digital representation of kind of the messy shades of gray that the real world is made out of, right? So we want both the ability to deal with analog and digital stuff. I think it's worth kind of going in slightly a little bit like what is a microcontroller, because people might kick this term around. It's just computer. Like they vary widely in their capability, but it's a computer. They're purpose built for like really, specific purposes. So they're going to be, as I say here, highly varied in capability, but they've all got memory, clock, I/O, storage, a CPU, like everything you expect a computer to have, right? There's just going to be some ways that they're a little bit different in terms of the architecture is going to need to be targeted by a certain compiler or whatever. But as we'll see in a second, TinyGo helps kind of smooth some of those things out. Less sophisticated though you can think of than like a full-on system on a chip like you would see in like a BeagleBone or in your phone or Raspberry Pi. So they're everywhere. Wait, pretty much literally everywhere. Like your dishwasher. I have a dishwasher that's like acting up right now, and I was like looking at this microcontroller. I'm like, man, one of your cousins in there, like pissing me off. Just blinking, turning on in the middle of the night. All right, so what is TinyGo? TinyGo is basically an alternative Go compiler, and it bills itself as Go for small places. And by small places, we mean like the tiniest of the tiny. Like we want to run Go like literally everywhere on those microcontrollers that are like in every device. They're in every car and every dishwasher and lots of toys, whatever. We want to be able to run Go like any place that's possible to run like an arbitrary computer program. So it was demoed this year in 2 major places, at OSCON and then also at GopherCon. Was anybody here at GopherCon this year? And see Ron's demo. He had his kid there, and they're like doing their whole little shtick. It's great. Ooh, that's a typo. It uses, not users, the Go compiler front end, right? So like we have the Go toolchain is written in Go, right, to actually create Go binaries. So what TinyGo does is says, okay, well I'm going to use the parser and sort of the front end of that Go compiler, but then I'm going to hand all of that to LLVM to create my intermediate representation, and then I have the full power of like all the supported LLVM backends that I can kick this out to, right? So if you're willing to do the heavy lifting, which I can't begin to speak to, so keep your questions to yourselves on like any internals of TinyGo for right now. Maybe like in a few months I'll come back to you with more. If you're willing to get to the point where you can control, like, or you can, create that LLVM IR, intermediate representation from the front end of the Go compiler, you can then send it to like anything that LLVM supports as a target architecture, which is this tremendous number of architectures. And as of LLVM 8, it's now in the main line that you can flash really common kind of microcontroller, which is an AVR microcontroller, which is what's on an Arduino. It's created by this independent developer who's just this like hyper smart right side of the bell curve guy named IQ Van Latham. And then Ron Evans, who is the main guy of this hybrid group consultancy that works on Sphero and did like some of the firmware for the little BB-88 drone thing that rolls around that you can buy. It kind of like, he's a GoBot guy, and he kind of took it and sort of ran with it and did some branding and like made a standard library and created some really interesting abstraction interfaces that make it easy as hell to program these boards. And they did this kind of to a certain extent, like because it's there, like let's do it. Like if you can run JavaScript on a microcontroller, then like why not? Let's run Go, because it's nice to write, and it would just be kind of a cool challenge. That's why I got started with it. But as we say here, like upstream Go wasn't really designed with hardware in mind, and you have like a lot of stuff that's already been done to help make this possible. The Go team thinks TinyGo is cool. It's just like it's not a goal of theirs to be able to run this on that kind of thing, but they think that this is a cool project or whatever. So there kind of is, if you care about these extra architectures, there kind of is a need to have this like separate sort of compiler for it and separate standard library. So a TinyGo program looks basically exactly like a regular Go program that you're used to, where you start with package declaration, and you've got your imports, you've got a main function, and because it's hardware, you're probably gonna have some kind of infinite loop, so I will always like doing a thing. You do get Go routines in TinyGo, which if I had more stuff kind of set up for, I have a workshop that this is kind of supposed to support, but we don't obviously have the hardware to go through right now. But it's very easy to just kind of be like, hey, go do a thing, and you just kind of watch this, watch this input or whatever, right? The kind of the same way you would program to get input from I don't know, an SQSQ or something like that. Like you can do some of the same kinds of semantics, except you're thinking about the hardware that you're talking to. So the first thing you might notice is like, what is this machine thing, right? Because it comes from a standard library. It's not, there's no like sort of domain import path there. And what machine is so cool because basically you can look at the TinyGo source code and see this machine abstraction uses build tags to, it first kind of has a generic set of things like pins and common interfaces for all these boards, and then it uses build tags to kind of like bring in the pin layout and the sort of specific things supported on any given board at the time that you're compiling for a board. So when you run a TinyGo compilation command, which we'll do in a second, you actually tell it, like, okay, I'm compiling for this supported kind of board. And it goes through and looks, okay, you've imported machine, so down here, it knows, for instance, for this board, like what hardware pin the onboard LED is actually connected to. And it knows that every board is gonna have an onboard LED, or every board in the generic sort of machine thing is. So I can just talk about that thing that way, right? And I'll show you some more code in a moment, but it's kind of hard to see sometimes code like this. But you can basically talk about the pins as you see them like silk screened onto the PCB. You don't have to do this sort of like math for the GPIO, or like do any of the sort of other like dealing with the vagaries of a Linux device subsystem and how that works. You can just be like, that's it, D12, that's the one I want, right? Which is one of the cool things about GoBot, but GoBot is like both a collection of drivers and like a sort of, I say this as a maintainer, like kind of a bloated library of a whole bunch of different things. Like you probably don't need like, you know, clients for NATs and stuff like that in there, but in any case, I digress. So yeah, this is really cool. Like you have, this is in that actual thing, right? Like all of the like dumb donkey work that like drives people crazy about trying to mess with hardware is kind of just sort of like abstracted away for you. And it's very, very easy. Also, if you're interested in extending TinyGo to like maybe some cool new board comes out next week and you want to go and like make it work for that, it's very obvious how to like create the pinout and just drop it in there and have like a very simple implementation of the quote unquote machine, which is, it's super powerful. It like eliminates a bunch of things that have always made me sort of annoyed with the way that GoBot is implemented. And like pretty clearly, like we're maintaining GoBot and stuff still, but pretty clearly TinyGo is going to be the way that people deal with Go hardware in the future. It's just so much more full featured in terms of how you can really run with it. Okay, so let's see if we can make this work. Escape from the Google Doc. All right. So this is not very big, I don't think. Can people see it okay? There? Okay. So, and these are red because like, I love GoLang, but it doesn't yet understand like weird TinyGo path standard library crap, right? Like it's like, well, I can't find this in any of your things, so that's why this is all red. So what we're gonna do here first is lesson 0. So this is like the hello world. This is kind of what I was showing that other thing in the slides. This is like the hello world of all hardware examples, which is where it's got an onboard LED, and we're gonna blink it, and you folks are gonna be just like massively impressed here in a second. I'm gonna blink this onboard LED. Let me tell you what. I can't afford to get one of those new things that finally has a good escape key. That'd be awesome, right? An escape key. Who says Apple doesn't make mistakes? All right, so we're gonna flash this right here. Okay, so we see like the target Arduino 933 port is just being stupid because I've got to double click this button because everything with hardware is hard. But it gives me an opportunity anyway to sort of say what we're doing here. So first, let's take a look at the device subsystem on Mac. So in case you didn't know, everything in Unix is a file, even your hardware. And that lives in here, right? So we go to root dev, and we're gonna grep for USB. So let's look at all the USB things that are plugged in our machine. Oh, sweet. We have a thing that pretends to be a TTY, which we can do all sorts of fun stuff with, and that's what it looks like, right? So let's go like this, and we'll just show ourselves we exported this earlier. So just make this a little environment variable. It's very nice. But that's saying like, hey, this is where the thing lives on my machine. When you want to send compiled binary code that's been nicely made ready specifically for this AVR microcontroller, somewhere it's going to be this place. All right, cool, got that. So TinyGo is there's kind of like a sort of like a Go tool, which is TinyGo, and it can do, obviously it's got some commands that make sense for hardware like Flash. So when I give it the target, I got to give it a target because that's how it knows. Like I was saying before, like that gets grabbed and used as like a build tag thing, right? So this is going to build our little program, and then it's going to go ahead and flash it. It is building it for the Arduino Nano 33. It knows to send the compiled code here, and the thing that we're doing is just this file. Okay, so we do this, and it's gonna think for a second. We also have a third-party tool we had to install called Bossack that allows us to actually do what just happened there. So like that's actually shelling out to a tool and pushing all of that to the board. And if you wanted to, you could scroll this. You could see like all the page boundaries. You could see like where the addresses start, and like every block that's being pushed everywhere into the chunk of writable stuff on there, right?
So now, don't everybody gasp at once, but every half second, this turns either on or off, right? So we've now, it's obeying us to do and say, yeah, we got it, 500 milliseconds, go us. Which is cool, but if we want to be able to get, something really awesome going, we would need at least this much for like an angel round. This much code would be great, yeah. So I've got a button here, and it is just this tiny little hardware button. I don't get any money from the company Seed, but if you ever get into hardware and you don't want to like tear your hair out like messing with resistors and all that kind of stuff just to get like a little circuit idea going and be like reasonably satisfied that you can achieve something, Seed with 3 E's is a cool company that makes these easy little breakout boards. And then all you gotta do is teach yourself to crimp the wires so you don't have to buy the rest of their dumb hardware suite. So what we're gonna do here is we're going to actually say, okay, we'll keep that same code that's blinking, that's cool, but we wanna be able to like get some output from our thing, right? Clearly we need to be able to like debug whatever's running on here. And I do this print line thing here because it's just funny. You can make it look like your like Space Invaders shots on the screen, as you'll see in a second. But before we do that, I wanted to show you this thing right here. How many of y'all have ever used the actual built-in for print or print line? Like not fumps.println or fump.print, but like printf, but like the actual built-in that's just print line, because you don't need to import anything if you want to kick something that's standard out. No? Okay, my boss has been writing Go code for like a really long time and like has sold a whole company full of Go code, and it didn't even know this existed until like 3 days ago, so I felt like really good for telling about this. But what it does is it's just gonna like, just kind of under the hood, it's like whatever, I know you want to send this to the process as standard out, so that's what I'm gonna do, right? So like you don't have a standard out on here, you have a UART interface, which if you don't know what that is, don't worry, it's just a universal interface that you can kick data around on, and they exist on pretty much any board you can think of. So what we can do actually is we can listen with screen. In case you didn't know, you can actually just sort of like listen to any interface with screen, and we can just pull bytes off of it at 9600 baud, and that is a standard out like write basically. So we capture the built-in instead of going to standard out. In TinyGo, the print line built-in goes to the UART interface, the default UART interface for the board automatically. So that's pretty cool because you can just do this, It's directed, trust me, to comma. It's my English degree. There we go. All right, so that looks good. So now, if I didn't pop any connections out or do any hardware stupidity, we should be able to flash this with lesson 2, which is indeed what we're looking at. And we'll do that unless it complains again that I need to double click the dumb thing. This is a reset button, which a lot of boards have, yeah. And you gotta say double click, put it into a mode where it will accept new firmware. Then we do this. Cool. So now we will actually, I don't know what that. Okay. We're gonna screen at that same device path, 9600 baud, right? Like, I never knew you could give a baud argument to screen for like a really long time, which, Ian's nodding and he's like, yeah, of course.
I just did this at work last week.
Really? Just last week?
Really, yeah.
Oh man, that makes me feel so
I
good.
flashed Linux on a 486 single board computer using Xmodo.
There's easier ways to play Doom, dude. All right, here we go. And let's see if we can do it. Pew, 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 pew. I press the button and it writes the thing. Isn't that amazing? And we didn't get to see Happy Birthday go. Why? Because this is every 10 milliseconds. It's like I can't have my cool video game arcade looking thing unless I'm polling every 10 milliseconds for button pushes. Because I don't, If I had an unintended wireless network available to me, I would show y'all how to send an MQTT message, which is like the message format that IoT is de facto standardized on. But it can't do that. This board will let me do that though. It's got a Wi-Fi radio, it's got a BLE radio. It's got this multi-tube radio chip, an ESP2 chip, which if any of you all have ever flashed a router with custom firmware like DDWRT, like you can kind of think that like in the small board hardware world, you do the same thing with this like super standard Wi-Fi radio stack, ESP stack, and you get a cooler Wi-Fi experience, or rather more control over it, right? So that's pretty much all I can show y'all now. My thing where I was like able to show the LED as a dimmer switch by like pulling values off the the knob is like suddenly not working, which is great because I have to fly with all this crap to Europe and teach people how to do it there. So I'm really feeling good about my crimping skills right now. Any questions about TinyGo? Yeah.
What's the tool that you said you use to flash?
It's called it's called Bossa. Bossa is the BOSSA is the company that makes this stuff. Once you get into hardware, you go and you discover this whole world of like acronym-rich crap that people already know, and there is no like decent map to a lot of this stuff. And all of the websites are from like 1996. So if you go look at like the Bossa website, it certainly looks like it's not been updated in 20-something years. But it has their name with a C, like Bossac, is just a tool. You download a package for whatever platform, and it's just this tool that lets you flash, right? So like when you want to do stuff with this, you kind of have to install a little extra crap with TinyGo. Like I have a homebrew. Well, now they've pushed it because it's in the mainline. But you used to need to install like a slightly later version of LLVM where it's like an experimental branch or experimental line where they had AVR support. It just hadn't fully made it into the mainline yet. TinyGo will target all kinds of things, but it'll definitely target WebAssembly, which is super cool. So obviously Go itself will target WebAssembly, but like one thing that when I was at GopherCon this last year became really obvious is that WebAssembly is going to be about as much to do with the web as JSON is to do with JavaScript pretty soon. Like I don't know, did anybody see the announcement? I think it was from Fastly that they have. You can run anything that will compile to WebAssembly, you can run, and they're guaranteeing like a function as a service, so guaranteeing a boot time that's measured in microseconds. Yeah. Which basically means like you can run like real crap at the edge, right? And all this like cloud terminology can be really cumbersome and annoying sometimes if you're not already steeped in it. But what people I think usually mean at the edge is if you've got on the edge of your network, maybe you're ingesting a ton of data, right? I work with some products that ingest like really large amounts of data, like several dozen terabytes a day, and the speed with which you can get that data in is a huge thing, right? So you're gonna run something like fairly beefy at the edge, right? You're gonna run Kafka, or you're gonna run some huge thing that's got to do some kind of computing is gonna have to be sitting there like at the front door to like really immediately process this and kind of move it on its way. And those kind of workloads are typically kind of a high price of admission. And the idea that you can run something kind of on demand sitting out there is really pretty compelling. I would also say the fact that like WASM is just like going everywhere now, and it's a reduced syscall set. Like there's a lot better security with it. Like I met people at GopherCon that work at like Capital One and stuff, and they're like, oh yeah, we're using it a ton internally in like weird little containers, which is exactly what Cloudflare and now Fastly have been productizing. So I don't know if anybody here is ever writing Go for WASM for like any reason other than avoiding JavaScript or whatever, but as TinyGo tries to kind of be the hardware Go, right? Like this to sort of be a thing, and it may end up being a pretty big deal. Ron has a ton of connections at Intel. He's been an Intel like an innovator several years, all that kind of stuff. And there are a lot of people who are I think pretty interested in the idea of being able to run this in really small places. But as you see, I think like WebAssembly get bigger and bigger, like it will also sort of get smaller and smaller, like in terms of like where we see it, right? So it's pretty cool that they kind of already got out in front of that and said that we're going to make like WASM a priority. Speaking of which, there is a TinyGo playground that is all done with the WASM with the WASM target. So like you can go and play around with TinyGo online the same way that you can with Go, and you can kind of mess around with its kind of limited standard library and whatever. But all of that is being compiled to WASM in real time to run, so that's kind of interesting. Anyway, other questions?
So TinyGo has like
Yeah,
Because normal Go is like 15 megabytes or something.
I wouldn't say it's quite 15 megabytes. It's gotten bigger, but like Hello World in Go is what, probably 2 to 3 now, something like that. It seems like as the GC's gotten better, the binary's gotten fatter, but it's not 15. But yeah,
If you include like HTTP.
for sure. Like Hello World is right. If you want to get a big complex protocol support and stuff like that, absolutely. Like to do network stuff for sure. It's dramatically smaller. Yes. You can if you go onto YouTube and you just search for GopherCon 2019 TinyGo, you'll see the talk that Ron gave, and he actually compiles to a DigiSpark, which is one of these like tiny SparkFun boards that's basically just like a barely programmable like BLE thing, I think, or Wi-Fi thing, right? So it's like, it's funny because when you plug it in, like the thing that plugs in your computer is like pretty much bigger than the board itself, and that thing is like, I don't know, a couple hundred bytes is what they're putting on there to just like do something like really limited, and I think the DigiSpark has something like 16 or 18K, but like just to blink the light on there it's something like a couple hundred bytes. It gets very small.
Do you know what the like performance trade-offs are? Or like what are you losing with TinyGo?
You're losing probably a lot of the standard library that you're used to. I don't know enough about like the way that this kind of programming is done professionally to be able to speak to like what the trade-offs would be with TinyGo as it's currently constituted versus like being able to leverage whole big tool suites or whatever that existing libraries or techniques that live out there. I mean, certainly this is just a few people's hobby project. But people that are far more versed in compiler design or hardware than I am, which is not hard to do, are getting very excited about this and spending a lot of time in the TinyGo channel on Gopher Slack. But yeah, like I think that the real thing that you would have to compare is like what are you giving up versus like other things you program hardware with, right? Because like you're throwing tons of stuff out the window just by running on microcontroller in the first place. Like you can't really think of it as the same kind of thing, right? Like there's a lot of concerns about. Oh, one thing I'd say you were giving up is you don't get channels. You get Go routines, but you don't get channels. Like it's just it's too much. I don't think they can think of a way to do it right now that wouldn't kind of apply an unacceptable amount of overhead to the sort of regular, like the cost of doing business of the runtime, right? The like initial, like I was saying, the hello world size would be larger. But you do get Go routines, so that in and of itself is pretty cool for this kind of stuff.
Is there anything special you have to do for memory?
Anything special?
Like is it GC or?
It is, yeah. Mm-hmm. Yeah, you should dig around in it. I think you would like it. It is extremely well organized. The TinyGo repo is like actually very easy to follow. So you can go in there and see the like the implementation, like because there's implementation of slice and map, right? Like in Go, but for TinyGo, right? So that's kind of interesting to see, right? The way that and a lot of it is just kind of they picked up some source, some BSD source because it's also same license as Go, it's BSD license. They picked up some source from Go and altered it a little bit, and they left the sort of top matter license declaration in place, right? But they kind of like made some small changes to it. Like for instance, I don't think that the hash key generation algorithm is different from what it is in Go, but I could be wrong. I haven't looked. Anybody else? Gary, look like you want to ask a question.
Me?
No? No questions? All right. Cool. All right. Well, thanks all. Happy birthday, Go.
Alright, well that's it everybody, and so we're not actually doing a December meetup, but I'll send out an email. There is like a big mixer event that somebody had communicated to me about.
There's typically like pan meetup, like a holiday party again. Every year, I think pretty much there's like 4 or 5 meetups. Like we're gonna have a bar tab or whatever.
So they stopped doing it a few years ago. They used to do the web meetup thing.
This one's Refresh Austin, I think, right?
This one's not Refresh Austin.
Oh, so the Refresh one is dead.
Yeah, I was curious about Refresh because it didn't.
Yeah,
Okay. Well, I'll see y'all in 2020. Hit me up about about talks. We don't have any speakers lined up for next year, so definitely looking forward to those. And sponsors.
Where's that link we're supposed to go? Is
I posted it on the
meetup? Okay.
yeah, on the meetup page.
I was just, if you want to message Blackwell
Okay.
for school talk, like I said, he wants to do one. It just he couldn't make it.
Okay.
So,
Yeah.
and then I'll say something to him in the morning.
Yeah, I'll say, I think all the dates for 2020 are already posted on the website. If not, it's the third Wednesday, so it's pretty far.
But in terms of no speakers, you know, that kind of year.
What's that?
In terms of not having
This kind of thing, like tiny go.
Yeah, but just so you have the date in January, and we're not looking to.
third Wednesday.
Yeah, third Wednesday. So hopefully,
Oh no, we don't have our
either get you all out there or get somebody.
What was funny was I was sitting there like, he could probably troubleshoot that in 2 seconds. But you won't be able to compile the gap, right? And then still with one side.
Yeah.
Oh, yeah.
It turned out to be way